Today, we will be talking about solving logarithm problems without using a calculator. So we have 5 practice problems right here involving logarithms, and we are going to solve each one of them without the use of a calculator. So let's get started. So first up, for problem number 1, we have the log base 2 of 16 minus the log base 2 of 8. And according to the quotient rule for logarithms, this expression right here can be written as follows. The log base 2 of a fraction, and specifically the fraction will be 16 divided by 8. Because according to the quotient rule for logarithms, the argument of the logarithmic expression, the argument of the first logarithmic expression in which we will subtract something else from, becomes the numerator of the argument of the logarithmic expression, and the argument of the logarithmic expression that is being subtracted from the previous logarithmic expression, well, that argument becomes the denominator of the fraction of the argument of the logarithmic expression. Now, this becomes much easier to simplify. So this right here, this will become the log base 2 of 16 divided by 8 is equal to 2. Now this is equal to 1 because 2 to the power of 1 is equal to 2. And so therefore, the answer to problem number 1 is 1. Now let us solve problem number 2. For problem number 2, we have 3 times the log base 10 of 2 plus the log base 10 of 200 minus the log base 10 of 16. According to the power rule for logarithms, this 3 right here can be written right over here. Let me show you what I mean. And so therefore, this means that 3 times the log base 10 of 2 is the same thing as the log base 10, and you don't need to write the 10 because if there's nothing written, that automatically means that the base number is 10. So this would mean that this expression right here, this logarithmic expression right here, would be equivalent to the log base 10 of 2 raised to the power of 3. And the log base 10 of 2 raised to the power of 3 is equal to the log base 10 of 8, because 2 raised to the power of 3, that gives us 8. So I'm going to erase 2 to the power of 3 and replace it with 8. Plus the log base 10 of 200. Now, according to the product rule for logarithms, this would be equal to the log base 10 of 8 times 200. And that is equal to the log base 10 of 1,600. Because 8 times 200 gives us 1,600. Now I'm going to erase all of this right here and just write log base 10 of 1,600. So now we have log base 10 of 1,600. Well, we also have to subtract from the log base 10 of 1,600 the log base 10 of 16. And according to the quotient rule for logarithms, this would be equivalent to the log base 10 of 1,600 divided by 16, which means that this would be equal to the log base 10 of 100, because 1,600 divided by 16 is equal to 100. Now, the base number is 10. 10 to the power of what exponential value gives us 100? 2. 10 to the power of 2 gives us 100. This means that the answer to problem number 2 is 2. For problem number 3, we have the log base 6 of 42 minus the log base 6 of 7. According to the quotient rule for logarithms, this expression right here can be written as follows. Log base 6 of 42 divided by 7. This is equivalent to the log base 6 of 6. And that gives us 1, because 6 to the power of 1 is equal to 6. Now let us solve problem number 4. For problem number 4, we have the log base 3 of 2.7 plus the log base 3 of 10. According to the product rule for logarithms, what we want to do is that we want to multiply the two arguments of the logarithmic expression. When we add two logarithmic expressions, provided that both base numbers are exactly the same. And yes, in this specific particular case, both base numbers are exactly the same. So this will become the log base 3 of open bracket 2.7 multiplied by 10. That gives us the log base 3 of, not 2.7, but 27. And this gives us 3. Because 3 to the power of 3 is equal to 27. And so therefore, the answer to problem number 4 is 3. Now let us solve the last and final problem. Problem number 5. So for problem number 5, we have the log base 8 of 72 minus the log base 8 of 1.125. Now, according to the quotient rule for logarithms, what we want to do is that we want to divide 72 by 1.125. What does 72 divided by 1.125 give us? Well, let's take a look. So 72 divided by 1.125. This is equal to, if you put it into a fraction, this will be equal to 72 over 1 divided by 1.125 over 1. Now, here's something that we need to think about. What does 1.125 divided by 1 give us? What is that equivalent to? It turns out that 1.125 divided by 1, that's the same thing as 9 divided by 8. So what I'm going to do right now is that I'm going to erase this and replace this with this. Now, remember that dividing something by a fraction would be equivalent to multiplying it by its reciprocal. So let us do that right now. So 72 divided by 1 divided by 9 over 8 would be the same thing as 72 over 1 times 8 over 9. Now, 72 itself, that is equal to 8 times 9. So 72 is equal to 8 times 9. Now the denominator 1 carries over, times 8 over 9. Anything divided by 1 remains the same. So therefore, for that reason, 1 is gone. 9 and 9 are also gone. So we are left with 8 times 8. 8 times 8 gives us 64. This means that, so just keep in mind 64 for now. So we just calculated that 72 divided by 1.125 is equal to 64. This means that problem number 5 can be written as the log base 8 of 64. That's what it means. Now, what is that equal to? Well, 8 times 8 gives us 64. And 8 times 8 is equal to 8 to the power of 2, which is equal to 64. And remember that in a logarithmic expression, what we're looking for is the value of the exponent. And we just found out that the exponent is 2. This means that the log base 8 of 64 is equal to 2. And hence, the answer to problem number 5 is 2. And this is how to solve logarithm problems without using a calculator